Okay, so let's look at Campi Flegrei right now. Oops, I don't know how I got on that. Hell? Okay, there we go. You can see no earthquakes. A couple little ones here. That's not an earthquake because other seismic station is not showing this. See, right here. That's most likely hydrothermal fluid just moving around in the crust. Or like really shallow. A couple little earthquakes here. Completely quiet here. Completely quiet here. So let's look at the uplift again. So that's subsidence right here. It's most likely going to resume. The uplift will likely resume. In my opinion, will probably end up somewhere at the 200 mark. So let's see. So right here, that's right around it's about 120. And now, right now, we're about 108.90. Maybe going down to 180, so that's probably a couple centimeters decline. But see how it's spotty like this? So it might just be a flattening out, maybe a little bit of a drop, and then it'll likely continue. This is what I'm trying to figure out. So it's a kind of an average, because see, there's like plots here. It definitely did not go up. Most likely flattened out, maybe even a little bit of a slight decrease. I don't think it's all the way down here. I don't think it's just, but it's showing a slight downward movement, and then it might just resume. I think we'll end up between 200 and 220. We'll probably end up somewhere around here. That's where I think we'll end up by 23.5, which is probably going to be around July. Because keep in mind, end of June, it's about a month away. So next month will probably be a little bit of an increase, probably be around 210. So we're definitely having about 100 millimeters of uplift in 6 months. That's definitely impressive. So if you look at an average of 100 millimeters, divide that by 6, that's about close to 16 millimeters a month of uplift, or 1.6 centimeters a month. So again, let's look at right here. So very rapid uplift here. I mean, there's uplift throughout the caldera, but RITE, the RITE site with a GPS tilt meter, very rapid uplift. That's a GPS seismic station. I mean, GPS tilt meter. Very rapid uplift. And then brief subsidence. In fact, let's look at other. Let's look here. Again, they're all showing a little bit of subsidence. Definitely a little bit of a change. Temperatures are steady. I mean, CO2 emissions are definitely higher than they were about 4 years ago. See, they were fluctuating between here and here, but now they're a little bit higher. See that slight increase? They're kind of stabilized here. See how there was a decrease in temperatures? But now they're increasing again. In fact, let's look at the monthly. Menthily. Here we go. This is monthly. Now it's June 1st, so they're most likely going to show May, probably later today. So let's look at uplift again. I know I showed this yesterday, but I didn't really have time to go over it. A number of earthquakes definitely increased. And I counted April and May, in fact. Let's do that right now. Okay, right now we're going to go into April. Yeah, a lot for it. Yeah, May's a lot more active. Let's see. One, two. Let's go right from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14, 15, 16, 17, 18, 25, 30, 35, 36, 37, 38, 39, 40, 45, 50, 55, 60, 65, 70, 80, 83, 84, 85, 86, 87, 80, 89, 90, 100, 105, 6, 10, 120, 128, 130, 31, 40, 50, 51, 52, 53, 54, 160, 170, 176, 180, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 220, 21, 22, 23, 24, 20. 24, 25, 26, 30, 40, 41, 42, 43, 44, 45, 46. 47, 48, 49, 50. That's 250. 160, 61, 62, 63, 64, 65, 66, 69. 70, 71, 72. 277 earthquakes approximately. So, what the heck just happened? Okay, so there are 277 earthquakes. One, two, three, four, five. Let me make sure. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 25, 26, 27, 28, 29, 30. 40, 41, 42, 43, 44, 45, 46. 47, 48, 49, 50. 60. 70. 71, 72, 73, 74, 75, 76. 80, 81, 82, 83, 84, 85, 86. 90, 91, 92, 93. 94, 95, 96, 97, 98, 99, 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 17, 18, 19, 20. 30, 31, 32, 33, 34, 37, 38, 39. 40, 41, 42, 43, 44, 45, 46, 47, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62. 5, 70, 75, 80, 85, 86, 87, 88, 86, 87, 88, 89, 90, 1, 92, 93, 94, 95, 96, 97, 200. 1, 2, 3, 4, 5, 6, 7, 8. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 32. 'What the hell just happened? Oh, there we go. 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55. 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 70. 78, 79, 80. 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 300. So 302 earthquakes. So we had about 30 more earthquakes here on this list than last month. Yet, here it says 671 for April right here. Look at that. See, February, April, February, March, April. See, and looks like we might actually have another increase. Here they're saying 675 earthquakes. See, it means they didn't show all the earthquakes. They probably showed the low frequency ones as well. And here it shows the depth of the quakes right here. What this looks like. Looks like the magma chamber right about here. The magma chamber between 1 and 3 kilometers in depth. Here's your magma plume. See how there's almost like a line? But see how it goes deeper? This is because of magma fracturing. I mean, magma pushing upwards and filling the magma chamber. This is what it looks like to me. Like, you're not seeing it spread out over a wide area. In fact, you're having two areas of earthquakes. These ones right here, and then very likely uplift and magma related earthquakes here. Some of these earthquakes are uplift related, some of them are magmatic. So far, there hasn't really been any harmonic tremors. We haven't seen any harmonic tremors. None. In fact, um, there's no harmonic tremors. I mean, you can see how quiet everything is. It's very quiet. This is not harmonic tremor. Because, look, it's not showing up on any of the other seismic station in the same area. Harmonic tremors, if there was one occurring, would be felt everywhere. It will be showing up on all seismic stations. In fact, harmonic tremors are normally, not always, but usually are a sign of a volcanic eruption. And harmonic tremors can also appear to be, like, they're usually felt throughout a large region. And it's caused by magma moving at depth. So it would be felt. It would be detected on all seismic stations. This is likely because of fluids, non-magmatic fluids. It could also be because of weather, but most likely this is hydrothermal activity. Very quiet. Again, almost no activity. So I registered about 302 earthquakes, give or take a couple. I might have towards the end, I kind of miscounted a little bit. I kind of lost my step. So I'm going to say between 300 and 302. So give or take a couple. So there's a little bit of a margin of error, give or take 2. So plus or minus 2. In fact, they always do that. Margin of error. This is all in Italian, but I can still understand what they're saying. See, they're saying what time the earthquake happened. Also going to talk about the uplift, events of earthquakes. Here it's energy. This is energy. These are events of earthquakes. Yeah, these are the frequency. I mean, things are definitely getting very numerous right now. So, yeah. I'm going to send this to Geology Hub. Yeah, I'm actually going to send this to him right now. Yeah, me and him, we communicate from time to time. I'm going to text it to him. April, period. Yet, when I visit their monthly update, it said that there were about 675 earthquakes in April. That means not all earthquakes are cataloged in the Seismolab. They usually reread the charts and add the ones that the Seismolab did not detect. I'm gonna send this to Geology Hub right now. men. So yeah, I just sent it to him. Hopefully he will be able to use this in his videos. Well, there's a lot more earthquakes now. Let's also look at the cumulative energy. See? Energia cumulativa. Cumulative energy. Yeah, that was when that there was those threes. Yeah, that was a pretty big storm. So yeah, so let's. I mean, we did have a 3.5 and a 2.7, so there might be a pretty significant jump. I'm not. I don't know if it's gonna be like this, but there might be a pretty good jump in 2000. I mean, for April. I mean, for May. So, see, I don't think it's gonna be like this. I mean, keep in mind you had a lot of jumps. I mean, you had a big swarms of earthquakes back then. I mean, the 80s were crazy. I mean, this is nothing like that, but let's look at CO2 emissions. That's heat. Let's go about 100. Again, the temperature in Celsius. There's an increase and a decrease. Anyway, geochemicals of the fluids. Yeah. This is what I want to point out. All right. Yeah, significant activity here. Okay, looks like someone's watching right now. Great. All right, I'm back. Actually, I'm gonna. All right, I'm gonna post this. All right, so let's move down now. Okay, so okay, I'm back. So let's go back up, and so now that people are joining, okay, this is the monthly update. So 671 earthquakes in total, 675 in totale. April 10th had over 60 earthquakes. Very active day. Yeah, so every day there's been some earthquakes. So not a single day that went by that there haven't been any earthquakes. Even here, there was one, and then boop, look at that 30 on the 30th. But when I went on Sismolab, it showed 275 earthquakes, measurable earthquakes. Most of the earthquakes are negative magnitudes. So let's go down. See, these are mostly negative magnitude quakes. In fact, we just here see 54% of the earthquakes were less than magnitude 0. So negative magnitude quakes. While the second most earthquakes were between magnitude 0 and 1. See? Less than 1 but greater than 0. Between 1 and 0. See that range right there between 1 and 0? Numero terrementi, so 22 earthquakes between magnitude 1 and 2, and greater than 2, 9 earthquakes. 9 earthquakes greater than 2. Still pretty impressive. The greatest earthquake was magnitude 2.9. But guess what? In April, May, we had a 3.5. So definitely there's going to be a big jump now. And also I counted total. I went on the Sismolab. I counted 30 more earthquakes, and most of them were here. So this might be higher this might definitely be higher. I mean, we might actually exceed 700 earthquakes for this month. For May, I mean. And see, this is the... Here's this Emergente Cumulativa Cumulative Energy. The biggest increase was in spring of 2021 right here. Look at that big increase. Boom. Yeah, there might actually be a pretty significant jump here. Yeah, this is 2022. Look at that. '23, '22. 22. So this happened in 2022, early 2022. Maybe I can go back and see. Let's go back here. Again, these are non-harmonic tremors because it's not showing up on any other seismic station. It's like quiet, nothing. Basically nothing. Let's go to Stromboli. Pretty quiet. Those little squiggles are saying those are little eruptions, most likely. No signs of harmonic tremors, nothing. Let's go to Avio Webby Quarters. There we go. Now we're looking at Alaskan volcanoes because there's been some pretty significant activity around Katmai. Yeah. Yep. Look at that. Good amount of earthquakes. Edgecombe. Yeah. Whoa. Look at Edgecombe. Edgecombe just had a swarm. Ooh, things are getting exciting. Edgecombe swarm. I'm gonna have to let geology help. No. Oh. However, most of the earthquakes, about 55% of them, were below magnitude 0. But there is a marked increase in earthquake activity at the caldera. Also, Edgecombe had another swarm yesterday. Not particularly noteworthy, but still. Let's see, 24 hours. No, that was a quick. Let's see, current. Hmm. 11 quakes. So let's go to earthquakes right now. Yeah, let's go to the latest earthquakes. Because yesterday, when I tried to look at it, I couldn't really find anything. But yeah, Edgecombe now is swarming. There's Edgecombe right. Actually, there we go. There's Edgecombe right there. There's Edgecombe. Yeah, they're only showing two, but clearly AVO showing a lot more than two. And oh, this was definitely a swarm. I mean, look at all these quakes here. Yeah, Edgecombe is definitely having a swarm, and Edgecombe is also uplifting pretty rapidly. It's not screaming imminent eruption, but it is uplifting. And Edgecombe does usually have explosive eruptions around VEI 4 or 5. So I'll send the link. I'm gonna. I definitely agree with your assessment on Edgecombe that an eruption might occur in a few years at most. Might definitely be pulling an El Chichon. Yeah, there's a chance that there's a chance that it might definitely be pulling an El Chichon. Yeah, the fact that Edgecombe is swarming, having a significant uplift, Edgecombe might definitely go boom. I don't think it's going to do it without any warning. There's definitely going to be warning. Like, there's probably going to be a lot of earthquakes, tremendous uplift, small eruptions before the big thing happens. I mean, this is just, in my opinion, this is just a precursors. These are just precursors. I don't think it's going to erupt this year. I mean, with every passing year, it's going to become more likely. I mean, there's also a chance that this unrest will not lead to an eruption. It could just settle back down. As Geology Hub stated, most, and not all intrusions of magma result in an eruption. In fact, Yellowstone had a basaltic intrusion Under Yellowstone Lake could have been rhyolitic, but it was a dike intrusion under Yellowstone Lake in 2009. Did not result in an eruption. Even a subsurface, it stayed underground. It solidified. Uh-oh. Unusual uplift at Yellowstone. Oh, wait, this is 2020. Uh, was caused by magma rising up deep beneath the surface, study finds. 2013, an area of Yellowstone supervolcano started rising at an unusually high rate. Over the next 2 years, it rose over 5.9 inches per year, the highest rate of uplift ever recorded in Caldera. 5.9 inches a year? Please. Yeah, Campi Flegrei is uplifting at a much higher rate than that. It's uplifting at almost 10 inches a year. Now, scientists said this unusual period of deformation was the result of magma deep below the Norris Geyser Basin. You know what's so funny? They made a movie saying and a magma intrusion in the yellow in the Norris Geyser Basin too. Wow. But here's the thing about Norris Geyser. It's actually to the northwest of the caldera. It's outside of the caldera. If an intrusion actually breaches the surface and erupts on the surface around Norris Geyser Basin, more than likely it's going to be basaltic. Yeah, basaltic magma. Because outside of the caldera, most of your eruptions will be basaltic. In fact, the last eruption at Yellowstone, actual volcanic magma eruption, happened 70,000 years ago. And it was a rhyolitic eruption. Geology Hub actually talks about this. Rhyolite is a very explosive magma, but if you take almost all the volatility out of the rhyolite, like say you release all the gases, you're just going to get sticky flows of rhyolite, which will be a whitish grayish color and will also result in obsidian. Yeah, there's also obsidian in Yellowstone. So it's not all boom, boom, boom. You also get basaltic lava flows outside of the caldera. In fact, the only reason Yellowstone, the caldera had super eruptions is because of the crust. It's because of where it's located. If the Yellowstone supervolcano hotspot was located, in a low silica, like say it was located off coast, offshore, and say the ocean, you would just have an island chain like Hawaii. You wouldn't have these super eruptions. In fact, more likely, once Yellowstone reaches east of the Rocky Mountains, the thickness of the crust will get less, especially since you had a shallow ocean in the middle of North America. More than likely, you'll start having volcanic fields like in Arizona. You'll start having cinder cones, some stratovolcanoes, some explosive eruptions, but also effusive. In fact, when the Yellowstone hotspot reached the surface about 20 million years ago, you had something called the Columbia River flood basalt. But at the same time as the Columbia River flood basalts, um, at the same exact time as when Columbia River, you had the flood basalt episode, around the same exact time, you had the first caldera forming eruption, the first super eruption, which formed the McDermott caldera. Yep, the McDermott caldera happened at the same exact time as a Columbia River flood basalt, which were in that same area. It was in southern, southeastern Oregon and what is today western Idaho. Yep, McDermott caldera is the name. Yep. Oops. 16 million years ago. Mm-hmm. By a lava dome. mafic lavas. Felsic. Mafic or less silica, believe it or not. The basalt. Yeah. Mm-hmm. See right here? Yellowstone hotspot. Yep. Look at that. McDermott caldera. But then why was it all the way up here? Significant displacement. Look at that, Nevada, Idaho. Look at that, Oregon. You had two calderas in Oregon because of Yellowstone. This is really interesting. Mm-hmm. Yep. It's actually very cool. And there's some inside as well. Seismic parabola. It's really cool. This is the hotspot right here. Here's the thing. Even going back over here, you also have volcanic activity going back into Idaho today, like craters of the moon, for example. Craters of the moon, for example. Of course, it's a result of Yellowstone, the Yellowstone hotspot. Oh, look at that. Basalt. Look at that. But your rhyolites are in this area. So you had caldera-forming eruptions because of the rhyolite. What happens when you get rhyolite mixing with magma? But basalt. Kaboom. When you just get rhyolite erupting without magma mixing, on its own, I mean, you'll get some explosive activity. You'll get mostly lava domes, uh, rhyolitic lava flows, obsidian flows. But yeah, you still get. Anyway, 2013. This is from 2013. 35 meters of uplift in just the last 100 years. That's definitely scary. Yeah, I'm gonna show this. I'm gonna send this to Geology Hub as well. Yeah, so the 2013 article stated that they found lake sediments that had been uplifted over 30 meters from the lake bottom, and they're stating it's likely in less than a century. They're concerned that basalt from below is intruding into the rhyolitic magma chamber. It may result in a massive volcanic eruption. Period. One of the scientists, his name is Singar, is saying that this has a lot of parallels to Long Valley, which had a history of erupting rhyolite, which formed Glass Mountain before the eruption 760,000 years ago. Singer. There are now concerns that a lot of basalt is now intruding into the magma chamber. May have a caldera forming eruption in the next few years to decades. Okay, let's okay. Okay, let's go back. This is a 2013 article. Let's find in. Here we go. 2018. Cold interior. Super volcano. Wow, this could get rather interesting.